Imagine you're an explorer, not in a jungle, but in a lab. Shells of colored powder and mysterious liquids surround you. How do you tell them apart? Without a common language, science would be chaos. That's why the IUPAC invented a universal naming system, chemical nomenclature. This secret language reveals exactly what a compound is made of.
And it is used to identify different chemical substances. For instance, compare table salt, or known as sodium chloride, with lead 2 nitrate salt. Both are white in color, but one is used for cooking, while the other can cause harm when consumed. With the help of chemical nomenclature, we can identify chemical substances for their proper usage.
In this video, we will focus on inorganic compounds.
There are four types of inorganic compounds that we are focusing on, which are ionic compounds, binary molecules, inorganic acids, and hydrates. Naming of ionic compounds start with the positive ions called cations. Metals with one oxidation number or charge keep their name. Transition metals with multiple charges show their charge in parentheses. In the olden days, they used suffixes such as "us" or "ik" to describe the different charges. Polyatomic cations or positive ions with multiple atoms will end with "ium." Continuing with anions, the negative ions. Monoatomic anions, which are anions with one atom, ends with "ide". Oxyanions, polyatomic anions containing oxygen, use "ate" or "ite". Oxyanions with more oxygen uses "ate", whereas less oxygen uses "ite". Have more oxygen? Use "per-ate". Fewer? Use "hypo-ite". Oxyanions with H+ use hydrogen, or dihydrogen if there's two. On a side note, using bi to replace hydrogen, such as sodium bicarbonate, also known as baking soda, is an old method. Now onto binary molecular compounds, or covalent compounds with only two elements. The more metallic element, or more electropositive, is written first. Based on the periodic table, elements closest to the left are more metallic. Using Greek prefixes, we can describe the number of atoms in a molecule. Mono, di, tri, tetra is 1 through 4, while the rest is similar to polygons, such as penta for 5 and deca for 10. The prefix mono for the first element may be omitted. However, Greek prefixes do not apply to hydrogen-containing molecules such as dibromane and ammonia. Moving on to inorganic acids. Their names are determined by the anion's suffix in the acid. By definition, acid contains anions and sufficient number of hydrogen ions to neutralize the charge. Monoatomic anions ending with "ide", it will be named hydroic acid. Oxyanions ending with "ite", the name is "us" acid. Anions ending with "ate" is named "ic" acid. Lastly, hydrates. The easiest one in the bunch. They're ionic compounds that contains water molecules within its crystal structure. The general name will be hydrate, then compound name. To be more specific, after the compound name, we add X hydrate. X is the Greek prefix. 6 molecules. It is named hexahydrate. If we heat the hydrated crystal structure until there is no more water, it will be then named an anhydrous compound instead. In conclusion, the nomenclature of compounds is implemented in the scientific field to ensure proper classification and precise identification of substances. Some compounds use Greek prefixes, while others have unique suffixes and others for easier distinction. It may seem hard in the beginning, but once you master the code, every name becomes a recipe and every formula a story.